There we go. All right, excellent. So good evening, everyone. Thank you all for attending. I'm happy to be here working with IEEE to bring you some more information, mainly about Mathworks, who we are, what we do, and some of the products that are already available to you, how they may help you in your current courses if you're not already using it, and then also how they'll be able to help you in your career moving forward. So let me go ahead and get started since Victor already gave me such a brilliant introduction. So for those of you that aren't familiar with Mathworks, Mathworks is the actual company that creates Matlab and Simulink. So Matlab is the actual product itself. I've had a lot of people always tell me, hey, how's working for Matlab? But yeah, that's more of the product, not so much the company. In either way, Matlab at its core is its whole purpose is to be a programming environment to allow you to do a variety of different things, whether it be basic computations, visualization, deep data analysis, and even creating your own algorithms to deploy onto hardware or deploy into apps, a variety of different things that you could even think of. But Matlab itself is just again, the core product. There are additional toolboxes and things that also come along with the Matlab package to enhance the different kinds of things that engineers and scientists can do. Mathematicians, statisticians, you name it. One of these other ones is Simulink, right? So Simulink is kind of like the sister to Matlab, if you will. It's a equivalent product in the sense that rather than programming, rather than writing code, you would be using block diagrams to express different equations or expressions that you want to create for whatever mathematical concept you're trying to either analyze or understand or beyond. So think of Simulink as an extension of Matlab, being able to come up with the same answer, except you're focusing primarily on using block diagrams to express it rather than writing code. So it kind of gives an option to users about how they want to interact with Matlab. And maybe if you don't know code, maybe Simulink might be an easier way to get started if you prefer block diagrams and visualizing your equations and things like that. But in the same breath, right? Matlab and Simulink are used to help define and test, analyze, and simulate all different types of parameters. So thinking about things in an environment where you can make mistakes, right? Doing things in a virtual environment before actually going out into the real world and doing it. So those are the two primary toolboxes that are, or primary products that are available. But there are over 100 different ancillary products that come with the Matlab installation and also come with what you all have available at UTD. And a big portion of this includes a lot of different artificial intelligence and data science type tools. So plenty of stuff. If you're interested in autonomous driving or autonomous flying, you name it, right? A lot of these different tools and things like that can be accessed within the Matlab environment to create your entire workflow. So to give you a little bit of background, so I've talked a little bit about the products that we have, right? I mean, outside of Matlab, we also have different services like training services, for instance. So we have a service in which our training division helps go out to train organizations, whether it be in industry, in academia, you name it. Anyone that wants that kind of training, they basically set up that opportunity and they go and do maybe a specific few-day workshop on getting those participants to learn more about what they're trying to do. So you have different options when working with Mathworks between looking at what we have as products, but also what we can do from a services standpoint. That brings me to the next slide in terms of talking about where Mathworks is headquartered. So we're a global company, right? We are located. Our headquarters is located in Natick, Massachusetts. So a little bit, like about 30 minutes outside of Boston. I'm actually located literally down the street from you all. I'm over in Plano, Texas. So we have our field office. We have one of our field offices in Dallas, where I'm out of. One in DC, one in Michigan, and one in California, two in California actually. And then, of course, as you can see on the map, all around the world. So, I have colleagues from all around the world that also focus on universities in their own respective areas. So this is a global effort that we're working to make sure that the people that are utilizing MATLAB get the best out of it and actually know what's available to them. I think one of the big issues that I found in my role so far is that a lot of universities have access to Matlab and Simulink, but many of the people that have access to it don't actually know what they have access to, where they can get it, or what it can do for them, or how they can use it. So that's kind of where my role comes in. Part of that, we actually have, at this point, well beyond 4,500, probably closer to 5,000, if not a little bit more. We've been hiring very steadily over the past few years from around the world. Since 2018, our revenues have been over $1 billion, and that's continued to rise as we continue to work both in education, industry, government, and also our services, including like pilot engineering and training. And then also we're a privately held company, which means there's only one CEO, there's no shareholders, there's stakeholders, that would be the employees, but there's no shareholders. So this may not be as important to you right now, but when you get out into industry, you'll realize that there are a lot of companies such as Boeing and others that are publicly held companies, and there's some subtle differences that you'll see between working for a public and private. They both have their pros and their cons, but just something to think about and consider. So to discuss a little bit more about the people that work for Mathworks, one of the big things we like to do at the company is make sure that we invest in the people that work there and make sure that they have what they need to be successful, not only in their work life, but also in their personal life or personal endeavors and things that they want to learn. So part of what Mathworks does is outside of your typical work, right? Part of your yearly call it work if you want, is a dedicated 40 hours or more on different trainings that you can take in the company to help improve your skills, whether it be soft skills or whether it be technical skills in a specific area, right? So whether you want to learn things more about leadership, or more about having tough conversations, or even learning more about, artificial intelligence or model-based design, things like that. 98% of our workforce at Mathworks have bachelor's degrees, so that's pretty much everybody, right? And out of those 98%, there's another 66% that have advanced degrees and masters. And then another bucket of that is 16% of them have PhDs as well. So we make sure to employ people that go deeper into their curriculum and well beyond, especially on our technical side when it comes to the engineering front line. So that's pilot engineering, training, application engineering, which works with industry, and then customer success engineering, which works with universities. Just to name a few of the different roles at Mathworks. As of right now, we're always continuously hiring. Job openings are going to be open and available, and I'll discuss some of those in a few. And again, I know you may not be graduating soon, some of you may, but I'll talk about all different types of opportunities that you have today and in the future. So moving on to, we've talked a little bit about who Mathworks is, the products we make, who our people are, but now let's talk a little bit more about who our customers are, right? Who are the people that we reach and talk to? And I think I touched on this a little bit before. So again, we have millions of people all across the globe in the majority of countries around the world that are utilizing MATLAB all over in their businesses, like I said, in industry, in governments, and in universities especially. So all the top, Fortune 500 aerospace and car companies that you can think of, they use this, absolutely. Obviously, I mentioned that Boeing uses this, and Airbus is no different. GM and all those other companies as well. And then also, what was also really interesting is 3 of the top 5 internet companies use MATLAB and Simulink for the work that they're doing. And those 3 are actually Google, Amazon, and Facebook. So just to give you another look at the different industries, right, as some of the different areas that we touch on, right? It's not just, I guess, if you will, engineering and science per se, right? We can get a little bit deeper into these areas, even financial services, for instance, even the medical and biological fields, right? Biotech, you think about that, communications, I already mentioned the software and internet stuff, even neuroscience, right? So, I mean, you can think big in terms of engineering and science for sure, but there's also other areas that currently work with our products and find applicability in the things that they're doing. So to give you a few of those examples, here's an example of Subaru utilizing advanced driving systems for how they can help brake during, let's say, a potential collision, right? How to be able to sense what another car is doing in front of them, right? They use these kinds of techniques that they model in Matlab and Simulink to help test out their car in a model in an environment which is safe and low from risk, in order to make sure that their car is actually going to operate safely once you actually get onto the real world and test it. Another example is Justin the Robot, who is a very cool device that was created by the German Aerospace Center to do a variety of different human-like tasks, to be able to see how the different degrees of freedom of a robot can work, right? Such as, being able to perceive and see a ball being thrown at him, being able to understand what it is, catch it, and even throw it back. And then here's another one from Georgia Tech that was actually one of my personal favorite stories that I like to share. Is, we talked about the bioengineering and stuff like that. There's, also ideas of advanced prosthetics where you might not necessarily assume that MATLAB and Simulink might have a place in, but it actually does. This gentleman here, he actually lost his arm tragically in a workplace-related incident, and he was a drummer prior to that, and so obviously it was impossible to continue doing the thing that he loved to do with just one arm. So his doctors got to working with some very smart folks from Georgia Tech to come up with a prosthetic arm that allowed him to continue doing what he does best. And I want to play this video for you, but okay, I have the volume set to a good standard. So hopefully this isn't too loud on your end. No, I mean, I just have to say, I mean, we look at technology and the things that we can do, and it's just amazing at how far we've come and what we've been able to achieve. So, I mean, you think this is cool. There's so many other things that we could do that we haven't actually done yet. It just takes that one person to ask that question. But again, I've talked a lot about, being able to work in industry, being able to work in research and things like that. But maybe that's not where your head is at, right? Maybe you may not be interested in working in industry. Maybe you want to take off on your own and do your own thing, right? Become an entrepreneur, open your own business, in a technical field, perhaps. Well, we do have opportunities for that as well. So what we have is what's called our Mathworks startup program, which helps build a bridge for those that are looking into the entrepreneurship space, especially in tech, to help reduce the software cost for you and the applications that are available in order for you to bring your prototype to life and bring it to market quicker, right? Bridging that gap with funding and other resources that are available are things that's part of the startup program to help those ambitious students to go to the next level if they so choose. Now, of course, neither of these things might be of interest to you right now, because maybe you may not be graduating. Again, some of you might. But for those that haven't graduated yet, that might want to get some more experience or learn a little bit more about what Mathworks can do, or at least the Matlab product suite, you should take a look into your campus as well. There are plenty of student competitions that are available on your campuses that the Mathworks does partner with. We partner with different main student competitions such as SAE, Formula, Baja, all these other different types of groups that are doing something a little bit more intensive. So again, we partner with a variety of different student competitions around the world, and we're continuously looking to work with more, right? Even this one where you have a automated boat race, or even autonomous robots that have to be able to work with each other on a field to play soccer. So a lot of cool stuff going on, a lot of opportunity where you can use MATLAB to help do the kind of work that you're trying to do, and be able to learn and gain those skills so that by the time you get to either internships or graduating, you have the opportunity to show off these skills. Now, speaking of internships and jobs, one of the things that I wanted to mention was some of the opportunities you have right now in front of you, right? For those of you that aren't graduating or at least have a year or so prior to graduation, we do have student ambassador roles and internships available. I'll talk a little bit more about the student ambassador role a little bit later, but as for now, the internship program is something that we call our engineering development program, or EDG, I'm sorry, engineering development group. And so what that is, it's a opportunity to get hired onto Mathworks as a new hire, right? Straight out of college with your bachelor's, and you get to be in a group where you work with not only will you be customer facing, where you get to work with some of our best customers, but you will also get to see all the different groups, like some of the ones I mentioned earlier, to figure out where you might fit best. So you get to work with a bunch of different interesting people to learn more about the areas that they're in, and then see if you might find a fit, right? There's really no set time limit on the engineering development group. At least for the internship role, there is, because it's a short-term thing. But when it comes to a new hire, this is when you get the opportunity to you would still go into the engineering development group as a new hire. So I'm sorry, I might have misspoke earlier, but that's more what I was talking about. You get hired on and you get to look into different areas to where you see you might fit. Some people figure it out in 6 months, some people figure it out in 18, right? To learn more about the different areas that they could work in. Like I said, the internship would work the same. You would work with the engineering development group, but of course, this would be a much more short time, about 3 months, because again, you're returning back to school. So with that, I want to just transition to kind of what's next. Where are we going? Where are we heading? What is on the horizon for technology and things that we're thinking about, or things that are already here that we're trying to solve problems with today. And as you can see, right, we're talking about putting software in everything. Artificial intelligence is a huge one. Autonomous systems, that's become far more prevalent in the past, 5 years, and so on, right? But again, with all these different mega trends and things like that that are changing in our world, things that we have to, see how they can work, we also have to understand how they adapt, how we can adapt to them, right? These are all cool, interesting opportunities, but we have to understand they come with difficult challenges as well. So for instance, let's talk about it, right? Some software in everything. What does that mean for cybersecurity, right? How can we protect vulnerable systems? These are questions that we should be asking as engineers and scientists when we start talking about what happens when we put software in everything. Just like artificial intelligence, one that gets a lot of hype. So if we're talking about, advancing how we work in artificial intelligence and many of the different systems that we use, like facial recognition and stuff like that, how do we ensure that these types of systems don't inflict harm on people? Or better yet, don't inflict harm on people because of biases built in, because of the way the data sets have been trained, right? These are things that have to be considered and thought about as you go through the development of some of these different products. So now we've kind of gone through some of the background behind Mathworks, who we are, what we do, and what we stand for. I want to talk to you a little bit more about some of the access that you actually have available to you at UT Dallas, so that you can get started and be able to use these products. Right? I've talked about where these things are used, how what areas are used in, some of the different products. Now here is showing you, if you're not already familiar, how you can access a lot of that different information. So the first thing that I always make sure to tell folks, especially at the university, is once the university purchases the campus-wide license for a Matlab campus-wide license for the university, that means it's open to anyone that's affiliated with the university. So if you have a UT Dallas email, you qualify to use, and you're a current student, you qualify to use the campus-wide license. All right, so that means unlimited access to all the different toolboxes we have, utilizing Matlab in an online space, which means you don't necessarily have to download Matlab. You could use it in a browser and utilize some of the same functionalities that are available. We partner with people like Arduino, which I'll get into a little bit later, so you can do hands-on learning when it comes to physical devices. And again, we talk about job opportunities, right? There's a lot of skills that are in demand, especially in today's age, where you have to know some kind of programming, right? So not only just programming, but how to think like an engineer and what tools can help you do that. So I'll share all these resources with you after the presentation. And I've hyperlinked all the different links here so that you can easily access the things you want to from these resources. The next one that I'd like to talk about is probably one of the most important ones, which is the self-paced trainings, right? These are modular-based trainings that you can do whenever you like. You can start a little bit, come back. You can do certain chapters and not finish the rest if you choose not to. But these are great ways to help get started with MATLAB. So what's complementary is these on-ramps. These are free to everyone, regardless of whether you have a campus-wide license or not. These help you get started with all the different areas, such as, AI, for instance, getting familiar with Matlab and Simulink, even more specific, like control design, like PID controllers or image processing, utilizing circuits. Obviously, I know IEEE, that might be a really good one for creating circuit diagrams and stuff like that, and even optimization. What comes with the campus-wide license, not only access to those, but even the focus courses below. So the on-ramps are about 1 to 2 hours in duration in terms of content. The focus courses, which come with the campus-wide license, are anywhere from 17 to 24 hours, right? So you have a lot more content, you go in a lot more deeper detail, and you get to use this as a training to be more familiar with a certain area within the MATLAB environment. Again, these are different accolades or accreditations that we provide certificates for that you can use in your resume if you so choose to show people that you have experience in these areas. I mentioned Arduino before. Again, outside of Arduino and Raspberry Pi, there are a myriad of different hardware devices that we talk to from all different breadths of the scope of technology. And we do that so that we can make sure that our tools can not only talk to these products, but also make sure that we have a workflow that allows you to not only code, but also test it onto the device that you want to use. That way you can see everything all at once and make it a seamless transition when it comes to deploying code onto hardware. Now, again, I know obviously MATLAB is not the only tool in circulation when it comes to programming. Python is a very popular tool that's used throughout the academic sphere mainly. And one of the things that I want to make sure that most people understand is that whether it's MATLAB or Python, it doesn't really matter. The bigger picture is that not only are you learning how to program, but I think the bigger thing to ask as an engineer or scientist or whatever is to make sure you understand the problem you're trying to solve and why you're trying to solve it. And I'll touch on that a little bit more later on as well. But the point I'm making with that is that you have to understand the problem you're solving so you can choose a proper tool to solve it with, right? There is no one-size-fits-all tool that will help you solve a problem. So you have to be able to know and decipher what that right tool is. So in an adage that my mentor has always shared with me, if the only tool you have is a hammer, every problem will look like a nail. So just something to keep in mind. But also, one thing I want to mention here is that you may end up having to utilize multiple tools to solve a problem, right? And so that's where this information comes in. You can call MATLAB from Python, you can do, and vice versa. You can call Python from MATLAB. So you have that versatility to utilize both products for whatever part of the problem you're trying to solve. So for instance, say you're doing group projects, right? And you're working with someone who uses one tool while someone else uses the other, and neither of you have experience in each other's tools. Well, this is where the bridge gets created to say, okay, well, you can still use your tool and I can still use my tool, and we can actually exchange data and information by being able to bridge this gap. And that's where the importance comes in, is being able to come up with a solution with a combination of tools, rather than just assuming that maybe one tool can solve the problem, which sometimes it can, but sometimes it may not. So this is just more information for you to think about in terms of how you're able to do different projects. Also, one thing I'd like to note is our MATLAB Central page. This is a great page for asking questions, getting started, learning more about all the different people that are using MATLAB in our community, talking on different blogs about different topics. But mainly, primarily, what I've seen is asking and answering questions, and also the file exchange, which is where our community puts out all their products that they've created as open source for you to go and use to your heart's content. So you get to utilize it in any way you want. You can either download or upload, so it's contributing or using the different files that have been created by our user community. So it makes it very worthwhile to investigate that area. So for instance, let's say you're trying to build an autonomous car, right? And you don't know where to start. And even though you have some training with Matlab and Simulink, maybe you might want to look for something that can help you get started, like a base model. And File Exchange would be that place that you can find base models or base code to get started with maybe the area you're doing. So basically, in a nutshell, don't reinvent the wheel if you don't have to. Finally, or rather, in addition, we also have been partnering more with our university contacts to do what's called our excellence in innovation projects. So think of these as like capstone or research projects that have relevance to the industries that you may be interested in working in one day. These are a variety of different projects that we've created with problem statements that you can go do and choose to go do. They're all available for free to use and check out. So, one of the things that we do is we make sure we try and encourage the use of MATLAB with these projects, because we want to show all the different types of workflows that you can actually achieve with our products to solve some of these different problems. So again, these are available and accessible to you. Use them for your capstone if you like, or research, or maybe just your own fun project that you want to bring a group together to learn more, to just learn. And then finally, one of the things I wanted to mention was we talked about internships and entry-level positions. Another thing that's similar to an internship is what we call our MATLAB Student Ambassador Program. So this program is essentially a student from the University of Texas at Dallas that would work with a math worker, me in this case, to help bring more awareness to different areas of UTD's campus, right? So this is like doing different events on campus where you can teach people how to use MATLAB, working with different faculty to see what you can do to help work with them in their classes, like almost like a TA in a sense. And then, there's also the opportunity to collaborate with different student ambassadors from different schools to get different ideas and figure out how you can be more creative at your own specific school. So there's opportunity, and this is about a 5-hour-a-week type of commitment. This is a paid position, so yeah, you're not just working for free. But yeah, it gives you an opportunity to not only get some kind of mentorship from the Mathworks side to see how we do things, but also gives you an opportunity to be able to be in a leadership position where you can teach some of your colleagues, or even learn some areas that you might be interested in to be able to go back and teach it. So I always say, it's one thing to read something, it's one thing to write something, but if you can teach it back to somebody, that means you truly understand it. So to wrap things up, this is all I have really on the Mathworks side of things. But to wrap things up, I'd like to just kind of leave you with I have 3 slides left that I want to talk to you about regarding just some thoughts that I have for working in industry, or what happens when you leave college and move on to your big job and stuff like that. But these are also things to think about while you're in school, right? So again, I've talked to you a lot about different jobs and things like that, but what I haven't talked to you about is what are the skills that these jobs might be looking for, right? What are the skills that this specific job might be looking for? What are the skills that the job that you apply for in the future after you graduate might be looking for? So let's talk about that, technical skills. I think when it comes to engineering and science, we need to take a very holistic approach in terms of how we look at problems. And I talked about this a little bit briefly earlier, is the primary thing we need to focus on is problem statements, right? Understanding what the problem is we're trying to solve, and why we're trying to solve it. The how is like the tool, for instance. So knowing what tool to choose and then figuring out how I'm going to solve the problem at that point. But that comes much later. If you can't answer the what and the why, reasoning for why you're doing something, you probably shouldn't do it. Or you should reevaluate to make sure you do understand it so that you know that there is a purpose and goal behind what it is that you're working on. Second thing that I've found very beneficial in my career is requirements. So think of requirements as constraints to your problem. These are ways to help bring an amorphous problem down to something that's more concrete. So basically something that makes it easier to solve. These are fundamental to completing projects such as, like, let's say in your capstone, right? Or even in doing homeworks and things like that. There are certain requirements that are being asked for in these problems, and you have to fulfill those. So these are just things to practice on and think about. Requirements gets much more deep than just the high level of what I'm explaining, but it's something that you want to keep on your radar for when you continue forward. I put it like this: requirements will be what saves, what either makes or breaks your project. If you don't define your requirements well in the beginning, I can assure you your project is not going to come out well. Or let's say if you're building a product, you're going to have a very hard time getting that product up to speed and making sure that it's working properly without defining your requirements accordingly. And both of these different things lead into what we call systems engineering, right? So this is thinking about things in a holistic manner. How does my system affect other things, right? It's like we talked about the mega trends, right? Artificial intelligence is cool, but how do we make sure it doesn't harm people, right? Software is great. We want to make everything autonomous, even toaster ovens, right? We want everything to have software in it. Well, that's cool, but how do we ensure that our cybersecurity space is safe? How do we make sure that these kinds of systems can't get hacked or are a little bit more impervious to being hacked, so that we don't cause disruption in the daily lives of people? So it's thinking about things as a whole. I like to think about it from my previous background being an engineer at Boeing, right? So I focused on building fuel systems, but fuel systems is one small part of a giant airplane. How does my fuel system interact with the wing? How does my fuel system interact with the landing gear? How does my fuel system affect the controllability of the actual aircraft, right? These are questions that I have to ask to make sure that our system is being designed so that it doesn't cause complications to the rest of the airplane. How do I indicate how much fuel is on board to the pilots so that they know at all times what they're working with? These are, again, it's thinking in a much broader sense versus, oh, well, I'm designing a pump for my fuel system, I'm designing a valve for my system, I'm designing, tubes for my system, right, for the fuel to flow through. These are internal, right? We have to think external. So how do we think about how our system affects things? And finally, one of the other technical things I think is going to be beneficial is model-based design. And a lot of what I've achieved in model-based design is through the platform of Simulink. This is really great because, like I mentioned, it's like building something in a virtual environment before ever having to build in a real environment, which reduces your time, reduces your risk, and reduces your cost, right? All beneficial things that you would like to do and also your company would appreciate if you did, right? This could be electrical circuits, this could be power systems, anything and everything, right? You can design a lot of these things within the Simulink environment to see how it might behave, right? So you can gain intuition about what the system you're trying to build may actually do. And once you can achieve that, then we can start looking at how you can build up the real thing and have more confidence that's going to work in the way you expect it to work. So I talked about the technical skills, right? Things that they're a little bit more on the general side, but again, these are the ways in which you think that you need to use to think as an engineer. Some of the other things that I mentioned is soft skills, right? Communication, organization, highly important in any field. You can be brilliant in science and engineering, but you have to be able to communicate your ideas effectively and openly, be able to take criticism also, and be able to bring your ideas together in a way that other people can understand. Because remember, you might not always be presenting to technical based people, but you have to convince those people that your idea is better. So you have to make sure that you know when and where to dial it back in terms of technical jargon or just high level information that people need to hear. And you'll notice that, especially if you have internships, you'll notice that the higher you go up the management chain, the less information they want, the more concrete deliverables they want. You know, the less it is about V equals IR or anything like that, right? They're not worried about the equation that you use. They're worried about what effect does this have on the overall system. And so that's kind of the way in which you have to think about how you choose to communicate and who you're communicating to, knowing your audience. Teamwork and interpersonal skills, right? This is highly important. You're going to be working with different people from different backgrounds, different experiences, different age groups, etc. Right? So knowing how to work with people, knowing how to connect and communicate and reach to those people is beneficial, right? Just like interpersonal skills. I know that there's a blanket stereotype that usually goes around about engineers and people in the science background that we're introverts. Well, to a degree, we probably are. But we can't let that define us, because there is no such thing as working in a silo when it comes to engineering something, right? We have to work as a team. We have to work cohesively, because at the end of the day, the overall goal is superior to that of the individual in the sense. So for instance, at Boeing, we used to say, I'm not the boss as an engineer. My man is not the boss as an engineer. The boss is the airplane. Because ultimately, we have to do our best to make sure that airplane stays airborne and keeps people safe. Another one, creativity and adaptability. You know, I talked a little bit about this earlier. How do you make sure that you continue to have that creative spark, right? People will say, you know, we've always done it this way, and this is how we know it. I'm sure many of you understand that technology changes faster than we tie our shoelaces. So we have to be able to adapt to the new things that are coming, such as AI and software and everything, right? As the industry shifts, we also have to make sure we make that shift to not only keep up our skills, but make sure to keep up in the sense that these things will continue to be safe and will continue to provide benefit for all of society. Finally, one of the soft skills that the last ones that I want to talk about that kind of speaks for itself is leadership, right? This can be at any level. It doesn't have to be management. It doesn't have to be a lead position. You could be a leader at the current level that you're at, whether you even be in school, in life. It's really about how you choose to operate and how you choose to work, right? It's kind of having these core values, what you believe in, what you think you should be doing, and how you should be operating. And you can operate and you can do these kinds of activities at any level. So leadership is for everyone, not just the people at the top. And speaking of leadership, you know, the last few things I want to say, it takes some courage to digest. So let's get to it. My final thoughts. These are 3 different areas in which that I've learned in my time in industry in the public sector. Learning more about what it really means to be an engineer and the things that you have to really consider. So number 1, the ability to question the status quo. So remaining curious. Remember I talked about, creativity. You don't want to get into a position, but you may, where people have told you, well, we've always done it this way. Again, that's the wrong question, or that's the wrong statement to make, because we know technology continues to change, and it's a very good possibility that we can do things better and maybe even do things safer, right? So never feel like because someone has said that means that you have to give up on the idea that you had. Continue to remain curious and ask more questions until you can poke holes into the theory that they had. And then maybe you can propose a better solution by organizing your thoughts and communicating that in a way in which they'll understand and point, well, they can't deny what you're saying and hopefully move and transition to that new space. Doing your due diligence, trusting but verifying. This is great because we all work in groups. We've all worked in groups for a long time, and we'll continue to do that once we go out into industry. One of the things you have to remember is that it's great to trust your colleagues, as you should, right? You see them every day. You're probably going to end up seeing them more than you see your immediate family. This is how it goes sometimes. But if someone from another team is giving you data that you need to fulfill the tasks that you have to do for your system, you want to be able to make sure that the data that they're giving you is going to basically do the right thing, right? You're going to get the answer that you expect. You don't want to just get handed off some data and it's not correct, because if it's not correct, guess what? Your answer is not going to be correct. Whoever you hand that off to isn't going to be correct, and it becomes a cascading issue, which means it may become an even bigger problem if it gets implemented and no one catches it. So when I say trust but verify, I don't necessarily mean you have to go and sit with them while they're doing their task and coming up with their data set. But what I am saying is that you should be able to ask the right questions to be able to understand if the data was made in a way that's going to support the work that you're doing. Finally, retaining a strong moral compass. This one is really important. Not giving in to pressure. You're going to experience many challenges, even in research, life, and even industry, where you may be told that you have to go do something that does not sit well with you or your conscience. It is important and imperative to understand what your core values are and choose not to give in to that kind of pressure. It is a-okay to say no. It may not seem so at the time, but again, your core values, the things that you believe in, are far more important than potentially putting people's lives at risk or in danger. Because that's what can happen sometimes when you give in to pressure, whether it be schedule pressure to get things done in a certain amount of time, where you glimpse over the engineering work and you don't spend enough time in it, which means you may get an answer that works, but it may not be the best answer, and that answer could end up costing lives at the end of the day. All right, it doesn't have to be an airplane, it doesn't have to be a car, it could be a washing machine, it could be an oven, right? It could be a record player. Again, we have to really consider what we're doing, how we're being asked to do it, and who it's going to affect. So, one thing I want to touch back on is that, when it comes to utilizing tools, right? Things that are going to help enhance your skills, right? They're going to enhance your skills, but they're not necessarily going to make you a better engineer. You have to actually choose to do that, to be a better engineer or scientist. So the points I've made here are just to help be a guide to get you there, right? These are my personal beliefs. These are things that I've learned and come up with over time that I found to be true, and things that I believe will be very helpful to you as you go through your own journeys. So with that, I'd like to conclude and open up for, I guess, the last 10 minutes for questions. And I can stay a little bit longer if Victor feels okay with that. If there's more questions, I'm happy to stay a little bit longer to answer them. So Victor, I will end my presentation now.
All right, sounds good.
All right. Yes. I will share it with you or Sarvan after the meeting, and you can distribute it to the folks that attended. Great question. So once you complete the on-ramps or any other online course, there is I guess, a button to the right of the course itself on the link that I shared, where it allows you to view or share a certificate. So once you complete it, you can go there and download it and keep it for your records. They are open currently. So some of the links are there in the deck, so you can follow those. You can apply there, and also for the student ambassador position, you can also apply there as well. So I have that all right in the deck. All those links at the bottom of the page, of the slide, will take you directly to get you more information. Could you ask that question once more? Well, it's not so much about the certificates itself, more so about the trainings. But I would say for those that aren't familiar, the MATLAB on-ramp is a great first start. Um, that gives you a nice, well-rounded view of what MATLAB is, along with a Simulink on-ramp. I think those two are great to really get started, to kind of see what path you might want to go, or maybe go both. And each of those on ramps, at what it does is it continues to build on the skills that you're learning through the on ramp, and at the end it has like kind of like a little project to go do to apply the skills that you learned throughout the on ramp. So I would say those two are a great start: MATLAB and Simulink on ramp, just for you to at least get familiar. And then if you want more in-depth MATLAB stuff, you can go to the MATLAB Fundamentals course, which is available to you. And that's a much deeper dive into MATLAB. But I would recommend doing the MATLAB on-ramp first if you're not familiar. All right, thank you, everyone.